So what are we going to do today? So basically now we are almost on the verge of finishing unit 2, which is around dealing with trig functions. Now we learned about how do we deal with trig and angle addition and the trig function related thing, right? We talked about sine, what is sine a plus b, cos a plus b, and how those formulas are derived, right? So and then we related that with the unit circle, and we looked at different types of angles that we can derive the trig function's value for. There's one more thing. So just to help you guys, not you guys, only you right now. So just to help you recall what we did in the last class, right? We talked about sine of a plus b was equal to sine of a cos b plus cos of a sin b, right? And then similarly we said, okay, how do we derive sin a minus b? That is where we applied unit circle concept and then we derived it, right? And then we looked at how do you find out cos of a plus b? This is equal to cos of a cos of b minus sin of a sin of b. Yeah. And then we learned about law of sines and cosines, correct? Here, and again we can find out what is cos of a minus b also by replacing b with a minus b and then see in a unit circle how that comes into play, correct? Remember that? What we did not find out was, how about tan of a plus b? How do we derive that? So we did not look at this formula, and this formula is tan of a plus b equals tan of a plus tan of b divided by 1 minus tan a tan b. And again, the same question still exists. Just give me a second. The same question still exists. How do we derive? I mean, how do we believe this formula? And why we are even trying to derive all this thing? Because this helps us to break down, or this helps us find out value of the tangent of different angles. When, let's say, if I have to find out tan of 145, I don't have to use the calculator for finding it out. We can find it using this formula also. I can break 145 into, let's say, tan of I was saying 105, I said 145. So I can break this into tan of 60 plus 45. And then I know the value of 60 and 1045. We'll plug that into this one and derive it. Okay. So the idea is, how do we use the knowledge that we have to find out more detail around it? But the question is, first of all, let's look at how this formula is even valid. Okay. So this will be much straightforward. We don't have to do much of a juggling with the things that we know. We just have to apply our knowledge of whatever we know. Okay. So if I'm talking about tan of a plus b, I wish Vedansi was also in the class, otherwise she will miss some interesting things that we'll see when it comes to application of these things that we're learning. Okay. So anyways, she'll have to watch the video and catch up on this. So here we are trying to find out tan of a plus b, and what we know is tan of any angle is equal to sine of the angle divided by cos of the same angle, correct? So I can write this tan of a plus b equals sine of a plus b divided by cos of a plus b. So far okay? Okay. Now, since we have learned about the trig values for the angle additions, we can apply that. Sine of A plus B is equal to sine of A cos B plus cos of A sin B. Yeah? This part is okay. Sine of A plus B equals sine of A cos of B plus cos of A sin B. This one we know. Similarly, cos of A plus B equals cos A cos B plus minus sin A sin B. So tan of A plus B equals sin of A plus B by cos of A plus B, and we just put the formula for this one that we have derived in the past. Sin of A plus B equals sin of A cos of B plus cos of A sin B, and similarly cos of A plus B equals cos of A cos of B minus sin of A sin B. Yeah. Now what we'll do is we'll divide all of them on the terms above and below by cos A cos B. So what we are doing is dividing this whole thing by cos A cos B and dividing this whole thing again by cos A cos B. Okay. So when you divide sin A cos B by cos A cos B, see cos B will get cancelled out, and this the first term becomes sin of A divided by cos of A. This one. We are dividing every term by cos A cos B, okay? So when we divide sin A cos B by cos A cos B gets cancelled out, sin A by cos A. That is the first one. Similarly, when you divide this guy with cos A cos B, cos A gets cancelled out, and then you have sin B divided by cos B. The first two terms. So I'm just dividing everything by cos A cos B, okay? Every term. So here when you divide this by cos B gets cancelled out, you are left with sin A by cos A. When you divide this thing by cos A cos A gets cancelled out, sin B by cos B. That's what you have here. Similarly, in the denominator, if you see cos A cos B, both gets cancelled out. This becomes 1 minus sin A sin B divided by cos A cos B. Nothing gets cancelled out. Okay. First term cos A cos B both got cancelled out. Here sin A sin B divided by cos A cos B. That's what I've written down. Yeah. So this thing becomes sin A by cos A tan A. Sin B by cos B becomes tan B. This one is 1. Sin A by cos A is this. Sin A by cos A is tan A. Sin B by cos B is tan B. So what it became was tan A plus tan B divided by 1 minus tan A tan B. So this is our formula for trig value for angle addition. Yeah. So that is tan A plus B equals tan A plus tan B divided by 1 minus tan A tan B. So there are three key formulas for angle additions for trig functions that we have learned so far, and those are, I'm just doing a recap of that, so that when we go into solving problems relating to this, we would be mentally ready for dealing with them. Okay. So first formula was sine of A plus B was equal to sine of A cos of B plus cos of A sin of B. Second one was cos of A plus B equals cos of A cos B minus sin of A sin of B. Third formula that we learned or derived was tan of A plus B equals tan of A plus tan of B divided by 1 minus tan of A times 10 of B. Yeah? These are the three formulas we learned. So basically, if you look at a summary of everything that we have learned with respect to trigonometry, okay, let's look at the journey. We started with Precalculus, that is where we define trig functions, what is sine, what is cos, what is tan. And then we realized that, okay, Precalculus works fine till we talk about angle up to 90 degree, meaning when we are dealing with right angle triangle. If you have to find out the sine of angle more than that, we have to go to the next level, which is unit circle. That gives us the ability to find out sine, cosine of angles or even tangent of angles more than 90 degree. We can keep going in loop and find out the trig function values for any degree that we want. Yeah. Then after that we said, okay, fine, right angle triangle is okay, unit circle is okay. Can we find out is trig function limited to right angle triangles or unit circle only? No. We can find out trig function values for any triangles. That is where we learned about law of sines and law of cosines. Right? So sine of A by A equal to sine of B by B equal to sine of C by C, meaning three sides and three angles, the relationship between them. Then we learned about law of cosine, where you know two sides and the angle between them, you can find out everything else. Then we went to learning a little bit more about how do you deal with different angles, or when you add angles. When you look at one angle in isolation, you can find out the trig function values. How about adding two angles together? How do we derive the value of any angle which is sum of two angles? And that is when we learn about these three functions. Yeah, that has been our journey so far. Correct? And again, I'm repeating this as a journey because I want this thing to be stitched in our mind. Tomorrow, if we come across any problem to deal with, we would know, okay, which method we are going to use, which weapon we have for getting rid of this problem or addressing this problem, right? Let's look at a few problems and see if those are actually problems or we are equipped to deal with them. Okay, so here is a word problem. Okay, I mean, again, I'm not trying to solve this, I'm just trying to make sure that we are very clear in our minds when we are trying to approach this kind of problem. Okay, if our approach is crystal clear, it is easy to deal with. Yeah? Let me read the question for you. Okay, Lisa is 800 meters from the base of a mountain. So let me draw it first, then it will make a little more sense. Okay, now we have a picture here. You can see there's a triangle. Here you see 49 degrees. And there's a question mark on this slanted side. This is written as peak, and this is the base of a mountain. So this triangle that you see, that is probably a mountain. That's what I'm trying to depict. Let's read what is there in the question. Lisa is 800 meters from the base of a mountain. So this is the base of a mountain. This is given as 800 meters. So probably this is where Lisa is standing. Okay, Lisa is here. Okay, and if you want to see what is this distance, this is a dotted line, and this distance is given as 800 meters. Lisa is 800 meters from the base of a mountain, as shown. From where she stands, she measures the angle of elevation to the peak of the mountain to be 38 degrees. So from here to the peak of the mountain, she is making an angle of elevation is 38 degrees. Okay. So she is lifting her eyes by 38 degrees to be able to see the peak of the mountain from this place. And this place is 800 meters away from the base of the mountain. She then walked to the nearest part of the base of the mountain. She walks to the nearest part of the base of the mountain. Lisa measures the new angle of elevation, this time getting 49 degrees. So basically from here to the top of the mountain, she is measuring 38 degrees. She walked towards the nearest point to the base of the mountain, and then from there she measures an angle of 49 degrees to the peak. Yeah? Now let's see what is the next part. How far is Lisa from the peak of the mountain when she is standing at its base? So it says, how far is she from the peak of the mountain when she is standing near the base? Meaning, it is asking us to find out this length. Okay? And then, yeah. So let's not try solving it. Let's try to understand. Let's wrap our head around this to understand what will be our approach for finding this out. Tell me. We are trying to find out this length. Okay? We know this length is 800 meters. This angle is 38 degrees. This is 49 degrees. And we have to find out this side. How will we go about this?
Can't you use can't you use some trigonometry to find it? Wait, no, couldn't you find you can find the angle of the outside triangle, you can find all the angles of those. Because if it's 49 inside, it would be 180 minus 49 on the outside.
Okay, so this one you are saying that you found that this is 131.
Yeah.
Okay. What do you do next?
You add up those two angles on the outside, subtract that by 180, and that's the answer for the final one.
So this becomes 169. So this angle is probably 21. No, 19 degrees.
Now we have all the angles.
Well, just give me 10 seconds to make sure that I am not putting anything wrong. 130 plus 130, 160, 169. So this is, yeah. This is 169. So this is 11 degrees, not. This is 11 degrees. Okay. What else?
I've expanded all the triangle. Now I can find. I can find out all the angles in the inside triangle now. Because, yes, you subtract 180 by the top one, the top outside one.
This one? This one?
Yeah. Yeah, so 180 minus that one.
Okay. But what are we trying to find out?
You're trying to find all the angles.
No, we are not trying to find out the angle. Our ultimate goal is to find out this length, here to here, correct?
We can use like trigonometry to find the angle.
So, sorry if I am cutting you in between. So here's the deal. Now look at this situation. If you are looking at this triangle outside, okay, we know this side, we know all the angles. So we know angle opposite to this side. This side is not known, that is what we are trying to find out, but we know the angle opposite to that also. And this is a classic situation where you use law of sine. What does law of sine say? Sine of A divided by the side opposite to that will be equal to sine of B divided by the side opposite to that angle equal to sine of C divided by the side opposite to that angle. Now in this situation, you know this angle, you don't know the side opposite to that. But you know this angle and you know the side opposite to that. You can just plug in that one to find out this side. So let's say this is wherever Lisa is standing, I will call this as L. Wherever the peak is, I will call this as P, and wherever this is the base, I will call it a B. So I'm essentially looking at the triangle LBP. Okay, I'm looking at the triangle LBP, and I see that in this triangle I know all the angles and I know one other side. I'm trying to find out the other side. I will use, since I know all the angles, so all the top ones are known. One of the bottom one is also known. If I take this formula, I can find the second bottom one, right? That will be by this side. So let's come to this triangle and relate to this the formula that we have learned, this law of sine that we have learned. So let's say this is this angle A, okay? So sine of 38 degree divided by the side opposite to that. This is what we are trying to find out. Let's say that is x, which we are trying to find out. Equal to, oh, this side is known, so I will pick this side and the angle opposite to that. So sine of 11 degrees divided by 800. So from that I can find out x goes to that side, everything else comes to this side. X equals 800 times sine 38 degree divided by sine 11 degree. Yeah? 800 is a number. Sine 38 we can find out. Sine 30 is 1 by 2. Sine 38 would be a little more than that. Yeah? Sine 11 would be somewhere, maybe, you know, we can use calculator for finding out these values, right? I mean, we don't have to worry about that. So what I'm saying is, that's why I was not insisting on finding out the answer. What I was telling you was that when you have a situation like this, that's why I was telling you the entire journey. So contour, right angle triangle, unit circle, dealing with larger angles, law of sine cosine to find out the relationship between sides and angles when you have certain things known to you. When you apply law of sine, when you apply law of cosine, right? And then you have the sine of a plus b, cos of a plus b, tan of a plus b at your disposal. Right? So basically, when you have this picture in your mind, I mean, I should not be disrespecting trigonometry as a subject, but what I'm saying is, you and me as somebody who claims to be, you know, getting ready for SAT exam or pre-calculus thing, this picture should be very clear in our mind. And that is the A part of my calculation. Because see, if we end up calculating this angle, see, imagine the path that we have taken, okay? We were saying, okay, this angle we know, we will find out this angle and this angle. But what we would achieve from that, even if, first of all, I have my doubts in place, if I can ever find out this angle and this angle. Because there is not much of information right now, okay? And even if we find that out in this triangle, there is no side known to us in this triangle. Let's say if we find out all the three angles by some means, but then none of the sides are known to us, then we cannot apply the law of sine or law of cosine. For law of sine and cosine, you need at least one side to be known to you, if you know all the angles, right? So, that is when, doing a quick recap of which approach I am going to take, which method would work for us given the circumstances. Even if you don't like this statement of mine, trust me, this is where you will decode that approach. Okay? Yeah? Make sense?
Yeah.
Yeah. Alright. So, again, solving problem, you guys can do it very easily, okay? I have no doubt about it. You are in touch, you are practicing things, you have calculator, everything you can do. But what is most crucial is this approach, decoding the approach that you will take for solving a problem, okay? And that doesn't need any AI. That just needs basic intelligence, yeah? I hope I'm making enough sense so far, right? Okay. So this was again, see what did we do was, we just picked up a problem, that was a word problem relating to trig functions, right? Applying trig identities. So even if the question was lengthy, but as soon as we drew the picture and then we kind of looked at it, did some scratch work, tried relating that with what we know, it's not that difficult. Most of the problems are like that. It's all about how do we simplify the problem that has been put in front of us. Okay? Now, we have a question, okay? Another question. And again, we will not try solving it. We will just focus on what is the approach or what would be the right approach to deal with it, okay? So, we are given a right angle triangle. And I hope, Arush, you can see the board okay, right?
Yeah.
Okay. We have this as 5, this as 12, this as 13. Okay? It says find out sine of, okay, let me give the names also, A, B, C. It says find out sine of BAC plus 60 degree. Okay? And we are given 4 options. Option A is 6 by 13 plus 5 by 26 root 3. Option B is 5 by 26 plus 6 by 13 root 3. Option C is 6 by 13 minus 5 by 26 root 3. Option D is 5 by 26 minus 6 over 13 root 3. Okay? So, this question is thankfully not a word problem, meaning it's straightforward. We have a right angle triangle, sides given are 5, 12 and 13. And we have been asked to find out the value of sine of angle BAC. So, BAC, this angle, this is 90 degree. Let me see if I'm missing something from the question. Okay, yeah, sine of angle BAC. So let me color this so that it's easy for you to relate. Plus 60 degree. And we are given 4 options. Tell me what is going in your mind, how do you approach this? Take your time, take a minute and then we'll talk.
Sine BAC, which is BAC. So you can find out angle, first you can find out angle BAC, which you can find out by using trigonometry. So BAC would be equal to 5 over 12. BAC, sine of BAC would be equal to 5 over 12, 12 over 13. So sine of BAC would be equal to 12 over 13. And we know that sine A plus B is equal to sine A times cos B plus cos A times cos B. Something like that. So, yeah.
So, okay. So BAC, I will give it a name alpha, okay, so that it's easy for us, okay. So this is sine of A angle plus another angle. You said it will be sine of this one, BAC.
Sine of A, so sine of A is 12 over 13.
Okay, let me not confuse it, sorry, my bad. Sine of BAC times cos of 60 degrees, second angle, plus cos of BAC times sine of 60 degree. Correct?
Yeah.
Sine A cos B plus cos A sine B. Yeah. Okay. This one you got as
BSC is 12 over 13.
12 over 13, okay.
And then cos is 5 over 13.
Sorry, cos BSc is 5 over 13, okay.
Yeah.
How about cos 60 and sin 60?
Can we use the calculator and put it out and then
Cos of 60 is 1 by 2 and sin of 60 is root 3 by 2. If you remember this table that we had prepared to derive the most commonly used angles 0, 30, 45, 60, 90, okay. Sin 0, 1 by 2, 1 by root 2, root 3 by 2, 1. Cos 1, root 3 by 2, 1 by root 2, 1 by 2, 0. And then sin over cos. So basically this value of sin 30, 45, 60, 90, these ones you'll have to kind of, you'll end up memorizing them actually. It's most commonly used angles. And why I'm saying so, because no, if you look at the answers here also, right, if you find out cos of 60, it will give you 0.5. Sin of 60 will give you root 3 by 2 when you, in absolute value, which will be 1.73 or something. And you will find that none of the answers match with that, okay. So here also the assumption is, we kind of are used to this table. Otherwise you will get some absolute value and you will not be able to match it with the options given here, okay. Yeah. So, what is that I was trying to do here? Whatever you did, that is perfectly fine. But, as I always keep insisting on is, we will have to keep on learning some dirty techniques, okay, for saving time. Now look at this. As soon as you came across this situation, sin of a plus b, that gives you sin a cos b plus cos a sin b. And every angle is less than 90 degree. When the angles are less than 90 degree, there is no negative sign that you are talking about. So, whatever be the value, I will not have something minus something as an option. So, I will simply rule out the two options C and D because both have something negative. Yeah? Without doing any calculation, okay? Sin of A plus B equals sin of A times cos of B plus cos of A times sin of B. All the angles are less than 90 degree, no negative. Option C and D ruled out. Yeah? Now when you look at this, you put this formula in your mind. Something, look at this. BSc gave you 12 by 13, cos 60 gave you 1 by 2. So first one is, it became 12 into 1 by 13 into 2, that becomes 6 over 13. So you have, by looking at the first term alone, now you have only these two options. My first term is 6 over 13. This is gone. This one doesn't seem to be an option. Option D is also ruled out. Just to be doubly sure, you have put the numbers here. And you say it's 5 over 26 into root 3. So in the option 2, they have flipped this, the fraction, okay? This is not correct. It has to be 6 over 13 plus 5 into root 3 by 26. They have just flipped it here. So I'll just go to this one. In this whole process, right, you will actually need only 30 seconds because our brains work faster than we speak, right? So here you will look at this one. Okay, I have all this is a right angle triangle. All angles are less than 90 degrees. I have been asked to find out this one. Sin of BSc, okay, sin of something plus something equals sin of A cos B plus cos of A sin B. All 90 degree or less. Negative options are ruled out. Now, what is here? Cos 60 and sin 60 I know. Sin of BSc is 12 over 13. Cos of BSc is 5 over 13. As soon as you see this number, you are straight going on to option 1. Yeah? So, again, all these things that we know, right? All these things we learn. These are the basic conceptual building blocks. if we are clear about it, solving any problem like this would be a cakewalk. And I want you guys to feel it like a cakewalk, because that is when I will start believing that I am doing my job right. Okay. Now, there's another question. We'll just look at this question and then I'll let you go. We'll keep it short because first of all, Vedansi is not in the class and we're just practicing some of the problems before we go to the next one, right? So, we will start with complex planes and that will be, so Vedansi, when you watch this video, you will have to just look at how the formula is derived and pick up some problems. So, this is a request for you both, okay? So, Arush and Vedansi both. I know Vedansi is not in the class, but I'm assuming she'll watch the video of the class. So, my request to you both would be, so far, whatever we have learned, you will kind of record that in your mind that, okay, these are the things we have learned and this is the reason why we have learned these things, okay? Why we have learned Sokatoga? We know. Why we have learned the rule of complementary angles? Why we have learned unit circle? Why did we learn law of sine cosine? Why did we learn angle addition thing? As long as that thing is imprinted in your mind, right? When you come across a problem, you will be able to connect the dots. Okay, fine. The other things I know, I'll use this because this is related to that particular part of the concept. Yeah. Let's look at one more problem, and we'll see how it goes. Here we are talking about a right angle triangle. This is 3, 4, 5. This is given as 90 degree. This is A, this is B, this is C. Okay. It says find out sine of 2 times BAC. I don't know what affinity they have with the angle BAC, but it's saying find out sine of 2 times angle BAC. How will you go about it?
Times BAC. So, can you just multiply the angle?
Yeah, I mean, think simple.
Yeah. So we already have the angle. Just find out BAC, so it's BAC. We'll just do what we did last time, right? So
BA, this is B, this is A, this is C. You are simply talking about this angle.
yeah. Okay.
Okay. So,
Define BAC, you would do
I'll give you 30 seconds to think about it. This is an interesting one, okay? Yes, Vikram.
Isn't it inverse function? So the inverse trigonometry. Yeah. So you have to use the 1 to the 3 power negative 1 and
So here's the deal, okay? Let me make it simple to you. Whenever you're dealing with a larger angle, okay, you can, when you have sine of 2 BAC, you can always say this as sine of angle BAC plus angle BAC. Is that okay? Sine of A plus B equals sine of A, that is sine angle BAC. Let me give it a name, alpha, okay, so that I don't have to write so much. It became sine of alpha.
You just do that.
I'm sorry?
So you just do the
Exactly.
And you have no like.
So I'm repeating the same thing actually. So it is equal to 2 times sine of alpha times cos of alpha. And my alpha is angle BAC. So it is 2 times sine of BAC. Sine of BAC will be 4 over 5 times cos of BAC will be 3 over 5. That's it. So all the trig angle addition function that we learned about, if you know one angle, you can find out the value of sine of 2 times of that angle, 3 times of that angle, 4 times of that angle. Okay? Applying these formulas. Yeah? Sine of 2a will be equal to sine of a plus a. So a plus a, you break it down. Sine of 3a will be equal to sine of 2a plus a. Now you have two angles, 2a and 1a. 2a you will again break into sine of a plus a, and then you can just go on. Only thing is, sometimes it's a very normal scenario where you'll say, okay, sine of a I know, sine of 2a, whatever value I'll get, I'll multiply by 2. That's a human error that we do. If we assume this to be same as, and this can happen, nothing wrong about it. But once we have this concept in mind, since we have deliberated this topic so much so in last 2 classes, that sine of a plus b is not 2 times sine of a, it's sine of a cos of b plus cos of a sine b. Cos of 2a is nothing but cos of 2 angles, sum of 2 angles is nothing but cos of a cos of b minus sine of a sine b. Cos a minus b is something different, right? So basically, net, these are the additional tools that we have added to our our defense for dealing with this kind of problems. So my request to you and Vedansi would be, after this class, just probably watch it for 10-15 minutes, just to make sure that you get the formula for tan of a plus b, and then whatever we have done with respect to sine of a plus b, cos of a plus b, or things in the past, go to this unit 2 on Precalculus, Khan Academy, okay? And try doing the unit test and see if you are able to solve all the problems relating to this or not. Okay? If you get stuck anywhere, that means there's an opportunity for us to learn something more about it. If not, from next class we'll start talking about complex planes, which is unit 3. Alright? Alright, with that being said, I will let you go. Enjoy the rest of your day, because there's no class in the afternoon. We will talk again next week. Yeah?